Hello everyone, welcome to the new video of Data Analytics. Today's video is about paired sample t-test in SPSS. We have already started the parametric analysis in SPSS and completed one sample t-test and independent sample t-test earlier. This video is specifically about paired sample t-test in SPSS and how to run and interpret the result. This paired sample t-test is also known as dependent sample t-test, and it is a statistical procedure used to determine whether the mean of two related measurements differ significantly from each other. It is applied when the same group of subjects is measured twice, typically before and after, or with or without an intervention, treatment, or experimental conditions. The main assumptions are the difference between the pairs should be approximately normally distributed. The observations are independently across pairs. The variables are measured in an interval or ratio scale. In this data set, we can see that the adoption level of ICT is measured before and after a training program is given to the respondents. Therefore, there are different data which is given in pair wise because there is only one variable, that is the score of adoption level, which we have measured before the training program and also after the training program. Therefore, we have to check, is there any statistical significant difference in the adoption level before the training program and after the training program allocated to the respondents. Here we have to compare the result by using different statistical measure. Before that, let us look for the steps of paired sample t-test. First of all, select Analyze. Compare means paired sample t-test. Here we can see that paired variables are grouped, that is variable 1 and variable 2 of pair 1. Here only one pair is allocated for the analysis, that is adoption level of ICT before the training and after the training. Therefore, we have to select the two variables as a pair 1. Before the training as variable 1, after the training as variable 2. Hence, we completed the first pair and click options. Here we can see that the confidence interval percentage, that is 95%. That means 5% level of significance is considered for analysis purpose. Then continue, thereafter OK. In the output view, we can see three important columns of paired sample t-test. The first column with respect to paired sample statistics, second column paired sample correlation, and the third one is paired sample test. From the paired sample statistics column, we can understood that before the training program, there is only 40.66 mean score and it is increased to 44.40 after the training program. Therefore, there exists a mean differences in the adoption level of ICT before and after training program. Hence, we have to check whether the deviation is correct or not with the help of paired sample test statistics. First of all, paired sample correlation shows the correlation value of 0.317 and significance value, that is 0.001. there exists a significant moderate positive correlation between before and after training program with a significant value of 0.001 at 1% level of significance. Thereafter, in order to check the hypothesis, we have to use paired sample test. The mean differences is minus 3.74. That means there is an increase from before the training program to the after training program by 3.74. Next, the standard deviation, standard error, the difference in standard deviation, standard error. Thereafter, we have to check the important result, that is test value, degree of freedom and significance value. The test value is minus 5.965. Significance value is 0.000. Since the significant value is less than 0.01, we have to reject the null hypothesis. That means there exists a significant difference in the adoption level before and after the training program. Then let us look for how we interpret the result in our research or project work. Okay. This is the result which we can show in our research or project work. Paired sample t-test is the heading. Then first of all, we have to set null and alternative hypothesis. There is no significant difference between mean score of adoption level before and after the training program. The alternative hypothesis, there is significant difference between mean score of adoption level before and after the training program. The table number which is given as 3, that we have already given table number 1 for one sample t-test and 2 for independent sample t-test, hence it is table number 3. Then the result of paired sample t-test, we have combined the 3 column into one table. The first part is related with the paired sample statistics of mean, n and standard deviation. The second part is paired sample correlation. Here we take the correlation and significance value. And the third part is paired sample test. Here we taken mean difference, t-test value and significance value only, and combined into the very important column of paired sample t-test. Hence, we can look for the interpretation. First of all, regarding the paired sample statistics, the interpretation is that the average score before the training program was 40.66 with a standard deviation of 4.299. After the training, the mean rose to 44.40 with a standard deviation of 6.126. The increase in mean suggests that on an average, participants have better adoption level on ICT after the training program. This is the interpretation of first part, that is paired statistics. The second part is regarding the interpretation of correlation. The correlation between before and after score is 0.317, which is moderate and positive with a p-value of 0.001. This indicates that subject who scored higher before the training tend to the score higher after it, showing some consistency in individual performance across 2 time points. And moving to the next column, that is the difference calculated as before and after is minus 3.740. The negative sign means after the score were higher, that is score increased by 3.74 unit on average. The t value, that is minus 5.965 with a 99 degree of freedom. The two-tailed p-value is 0.000, which is less than 0.01, so the difference is statistically significant. Hence, the null hypothesis is rejected at 1% level of significance. There exists a significant difference in the adoption level of ICT before and after the training program. Moving to the overall conclusion, The training program significantly improved the adoption score. The effect size can be considered moderate to large given t-value and noticeable mean increase. Practically, the program is effective in enhancing adoption level of ICT. This is the style of interpretation we have to given after the paired sample t-test result and its table creation in our research and project work. And we have combined the three table into one, and let us look for the interpretation after testing your result. Okay, this is the video about paired sample t-test. If you have any doubts, please comment below. Thank you for watching.